Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Triangulation is brought to you by Cachefly at CACHEFLY.com. This is Triangulation with Tom Merritt and Leo Laporte. Episode 40, recorded February 15th, 2012. Bram Cohen. Triangulation is brought to you by Ford, featuring the EcoBoost engine with turbocharger and direct injection. Look for EcoBoost on the 2012 Explorer and Edge and the 2013 Escape. And of course, at Ford.com/technology. It's time for Triangulation, the show where we gather, Tom and I, to gang up on a big brain. And usually we figure between me and Tom, we can kind of, get to the root of the matter.
We often encase the brain in a human compartment.
Exactly. In this case, I think we're going to fail entirely because we have really kind of an amazing guest today. Bram Cohen is here. And you may not know the name, but I'm sure you know the word BitTorrent. Bram is the creator and founder of BitTorrent.
Yeah, I invented BitTorrent.
You invented it. Programmer. It's nice to meet you, Bram. Mm-hmm. Yeah, you're kind of legendary.
Yeah, that's heard of.
He's not imaginary, but you're well known. And I think you did a very interesting thing because a couple of years ago, BitTorrent had gotten a reputation, I think, as a piracy tool, and you formed a company and you took venture capital, right? And,
yeah.
And was that an attempt to make it go serious, go commercial, or?
I always had the goal of having it be used. It's like the whole point of it was there's this hard problem of you want to distribute a really big file to lots and lots of people, and in principle there's plenty of upload capacity in all the peers. How do you utilize that effectively to transfer these big files in a reasonable amount of time? And so I set out to solve that problem, and I figured out how to solve it. And it wasn't everyone likes to write the story of BitTorrent goes legit, but it was.
It did sound like that.
Yeah.
You were legit from the beginning.
Yeah. It was like, here's this technology, and anyone who wants to use it, I'm very happy to help them use it. Blizzard used it very effectively way back in the day.
Still do.
Yeah, right. And unfortunately, there's a lot of resistance to that sort of this.
Well, BitTorrent hasn't avoided getting thought of as a tool for infringement by a lot of people. But how did you avoid getting slapped with being identified as a company with being infringing? The way Napster just had no hope.
Well, Napster was very directly,
is it because the technologies were different?
The technologies are very different.
Yeah.
That Napster was very directly involved in running actual servers to look things up and things like that. BitTorrent is more like a web browser. You can use it for whatever you want, and we just make the software and push it out there and let people do, whatever they want.
It really was as much a specification, too, because many have written BitTorrent clients. It's not...
Yeah. There actually have been many BitTorrent clients over time that were written by different people and interoperate with each other just fine.
Right. There's the canonical implementation, which you did, but there's so many. There's microtorrent. I mean, there's a million of them.
We actually, the microtorrent is basically, or utorrent is basically the official one now.
That's the official one?
Yeah,
okay.
That's the one that we maintain.
Got it. This explains why it's the best. I just want to say that. And I'm supposed to say uTorrent, not because I think it's a micron, right?
It's funny because the domain is uTorrent, and we got into calling it uTorrent because the guy who wrote it called it uTorrent.
Right.
But the actual symbol is
a micron.
Yeah.
So, all right. So I'll call it whatever we call it.
Linus or Linus or Linus. Or...
So how did you get started in programming?
My dad taught me how to program when I was 5 years old.
Was he a programmer?
No. He was a journalist, actually. He eventually went back to school, and he's a computer science professor now.
Oh, how interesting.
But he taught me how to program, starting on a Timex Sinclair and stuff. And I remember, learning to just use a print statement. And
when you were 5?
Yeah. Well, my ability
cassette storage?
Yeah.
Right.
And you could actually listen to it.
Yeah.
And it made sound. Yeah. It's way more high-pitched and annoying than that. But
I can't get that.
But my ability to read and my ability to program were always kind of comparable, on par. And I had a pretty good intuition for a number of things in terms of basically understanding this fundamental concept that all computers are basically the same. They have different I/O capabilities, but in terms of what the central process, but in terms of once you have a programming language available to you, you can write a program to do the same thing as any other program as long as you have a general purpose programming language available. And I kind of got that intuition at a very young age. It didn't mean I was a good programmer. I wrote a program to play Connect 4 when I was like 12 years old. And you know, I spent
BASIC?
No, actually it was in this language called PROMAL, for Programmer's Microapplication Language. It was a compiled language for the Commodore 64 and Apple IIe, which had a simplified enough syntax that you could actually fit a compiler for it onto those machines. So you could actually make things that ran in.
So you just loaded off the disk? Is that how it worked?
Yeah. And it was a very backwards environment in many ways, because it would run for 20 minutes compiling your program, and then would tell you one syntax error, and then you run it again, and it would tell you a syntax error in the next line right after the one.
Sounds painful.
Yeah, well, and because I didn't understand all that many concepts all that well, I wrote this thing for playing Connect 4, and I wrote the thing for doing the 1 move look ahead, and then the thing for doing the 2 move look ahead called the 1 move look ahead, and the 3 called the 2, and so on. And this went for like 8 or 9 until I kind of figured out the pattern and actually wrote it recursively.
Yeah, I was going to say, you learned at some point you learned recursion, and then
Yes.
But that's a big leap in a programmer's development, is that?
Yeah. Well, the funny thing is, I was really writing it in a horrible way, because my dad didn't actually teach me local variables. So I allocated global data structures up front that were big enough that I could use them, and passed in the level of iteration to every function, and it looked up and they raved the global data structure for everything it needed. So it was really
very powerful, but not what you needed.
It was very clumsy code.
Yeah.
But it did work.
Was he? So he wasn't a programmer. He was a journalist. What kind of? Was he a tech journalist, or was he
politics? And
politics,
stuff. Yeah.
huh? But he must have loved computers.
Yeah. That was his big hobby was programming, and he programmed in BASIC, and he got PROMAL and stuff in PROMAL. He actually there's this computer game called Core Wars, which is really a programming game.
Love Core Wars.
Yeah. There was actually there's the short-lived Core Wars newsletter, and it actually wrote me up one time because I was 12 years old. And
so the game was you would write an autonomous beast.
Yeah, a program to fight other programs. And there was actually one competition of that, which I did pretty well in. I feel I kind of got stiffed, but I should have won. But I wrote this one called Power Bomb, which it wasn't really optimized properly for the actual competition, because they didn't have clear upfront rules about how the competition would be done. So they ran an early round in some ad hoc manner, and they figured out what the 5 best programs were. And 2 of them were ones that I'd written. And there's my good one, Power Bomb. There's another one called Random Fire, and Random Fire was sort of Power Bomb's Achilles heel, and I wouldn't have submitted it had I known that they might actually do this. And then also there was this weird
because you wrote the program, so you knew where the weaknesses were.
Yeah. So there was this other thing where Power Bomb scored pretty much 100% against basically all the weak programs, except for these other 4. But because the last round only included the top programs, I didn't come out top. Where if it had been a round robin with a larger number, I would have clearly won. So anyhow,
you wrote a 2 general purpose killer.
Yeah, well, there were some other mistakes I made.
How old were you when you were doing that? That was 12.
Yeah, I was 12.
Yeah. So did your dad, did you go to your dad and say, I want to learn this? Or did he just have an intuition that
my
you'd be
dad
good at
actually
this?
wrote an integrated Core Wars development environment on the Commodore 64, which is what I used.
I love this. So he played too?
Yeah. Well, I think he was more interested in the development environment.
Tools.
Than,
He liked the tools.
Yeah.
How interesting. So that's a nice way to connect with your father.
Yeah.
You still talk at that level and talk about technology? Was he interested in BitTorrent?
Yeah, he was. Although it's he didn't contribute to BitTorrent development, but I tell him about these things.
It's nice that your dad can understand what you're doing.
Yeah.
Let's put it that way.
Understand what you do. Yeah.
That's great. Yeah, and you were also kind of a math whiz.
I tend to think that I wasn't that great because I was the second best person in my year and kind of a weak year.
Okay, I'll take it.
And we were talking before the show about, the math you use in programming is not the math you use in a competition.
Well, there's so little math you use in programming. It's like there's these core concepts of algorithms and asymptotics, and you like never like get to use anything interesting. It's all like low exponent polynomial and exponential time for everything you ever touch. And so I like at one point had to I'm passing around bit fields that tend to be very biased towards ones or zeros. And I got a little bit, I was thinking about how you could compress these down and start to get an intuition. And so, of course, the modern method of research, I tweeted wondering if this has actually been a known field of research. And of course it has, and a few people responded and got me on the keyword to get the actual answer. And I wound up looking up Elias Omega encoding on Wikipedia, and I went and spent a day implementing Elias Omega encoding, which was lots of fun, and that was good to do. But I was just so excited to get to use something almost sort of like real math in my job.
Exactly. And then when you went to college, you were not exactly able to find something that kept you interested?
Yeah, I dropped out of college after a while. The introductory coursework was like all stuff I already knew.
Because you'd have been programming forever.
Yeah, for a really long time, and I just had college wasn't for me. It wasn't my thing.
But you wanted to keep programming.
Yeah. I wanted to like do something that was like I wanted to do something that mattered, and so that was a big part of my leaving college.
So where did you go from there when you decided, you know what, I want to keep programming? Where did you go to keep programming that kept you interested?
I don't know. I worked at Kinko's for a while, and then they fired me for having an insubordinate attitude. That was the actual official reason given.
What did you do?
He was insubordinate.
I was insubordinate. I didn't play along with.
You made 29 instead of 30 copies.
No. I really...
Rebel.
I actually know exactly the situation you're talking about. But it's so silly what they consider insubordinate.
Well, sometimes there are things where you're told to violate official company procedures for how you're supposed to do things, and I wouldn't do that. And there were things like that. But I eventually got a job at a startup called EarthWeb, which was sort of a big hyped thing back in the day, which had this site Gamelon, which was this index of Java applets when this was a really hot thing. And it was just such an exemplar of the whole .com flameout of a company that raised a whole bunch of money, did a whole bunch of acquisitions, like blew through tons of money, had all this amazing promise, which everyone there was all excited about, and just piddled around, was interested in getting their big IPO and stuff, and that was about it. And the funny story about that one later was they acquired, among their acquisitions, they acquired this company called Dice, which is
still around. It's a job search
it's a job search site. And eventually, all the operations other than Dice were shut down. Except I think they were still like managing it out of the offices in New York City, because I don't know why, because the offices in New York City had run everything else into the ground. At some point, they tried to launch a new version of Dice, which just failed. They launched it, and then they wound up reverting back to the old one. And eventually, even that was run into the ground. And it actually, the story I was told about it was that it was acquired by the guy they bought it from.
Like, you're killing me. Give it back.
Yeah. Well, it was, he got it for less than he sold it for, because all his money was from the original sale. And then he turned it around and he sold it again a second time, making a good profit on the thing.
It must be difficult. You're now running a company. Or are you running?
I'm not the CEO.
Okay.
I'm pretty happy about that.
So when you
I'm
started,
happy when I'm coding.
When you started the company, you didn't want to run a company. That was never.
Well, I was the CEO for a while.
Yeah, you have. I mean, I'm reading your blog. You have good ideas about managing and how to run a company.
Yeah. I have ideas about things, but like in terms of what one spends one's day-to-day time doing, I think it's one of these things where it's like if you can really code, you just don't feel productive doing anything else at all.
So you still code? You still like to code?
Oh yeah. I've spent the last couple of years doing pretty hardcore coding on this very researchy project.
You want to talk about it?
Yeah. I've been working on peer-to-peer live streaming. So BitTorrent is for transferring of data that's been around. It's pre-recorded. There's a whole big file. You want the whole big file, and you download the file. And there's this feature of downloading it, doing playback as you're still downloading. Which can be done within BitTorrent protocol. In fact, we support it in utorrent.
That's interesting, because BitTorrent is not at least my understanding of the protocol, it doesn't create a file in order. You watch the file and it creates it at all different bits, right?
Typically, when it's downloading something, it will download the pieces in kind of random order.
Right.
There's no super deep reason why it necessarily has to do that. There are reasons why it's generally a good idea, but it's okay to do some amount of downloading in order starting from the beginning and going. But if you watch what you've actually downloaded when you're doing playback from the beginning, it's like it's downloading from the beginning and also
it's still doing the other stuff, yeah.
Doing bits elsewhere. But it can only do that as it like kind of gets ahead.
Right.
But that's not what I've been working on. What I've been working on is a very different problem of like what you see on television. There's something happening right now, and you see what's going on right now, and there's no archival storage. It's not keeping this around for later. It's just playing it back,
right? And
the data's gone. And this is it's not
true streaming.
Yeah.
Not kind of like hinted playback as you're downloading. True streaming.
Right. True streaming. And this is an extremely, extremely technically difficult problem to solve.
Don't we know it?
Yeah, you're trying to...
We know all about that difficult problem.
Yeah, well, I've been surprised because we've actually been getting it working really well on a few deployments lately.
Interesting.
So there's still a little hit or miss, but some of them have worked really well. And what's surprising is when a deployment is going really well, I'll like notice the end-to-end latency is like really a lot worse than I think it should be, given what Core is doing. And they'll notice that basically we'll have some kind of Rube Goldberg contraption on the back end, and that's adding like a couple, like 2 or 3 seconds of latency, which is like sometimes more than the actual peer-to-peer latency.
Wow.
Going between peers at the end. And it's just this horrible thing when you're dealing with live stuff where every single layer of abstraction that everything is going through is adding latency and another single point of failure for the whole thing to just fail.
We just recently learned, we're using Canon camcorders, that the camcorder has significant video latency.
Yeah.
So what they do if you're recording into the camera is they just slow down the audio and so that it all matches up. They put a time delay in the audio. We never noticed that, and so we just recently realized that we have several, I don't know, tens of milliseconds delay between the audio and the video.
Yeah, well,
and that's just the first thing. And then there's another one and another one.
Yeah.
It is a Rube Goldberg.
They all add up. And actually notice sitting here, there's this video cameras here that like you can hear the person actually talking from over here. So there's, like, I don't know, like 10 milliseconds of latency just because of the speed of sound from over there to over here. Right. But there's like a noticeable lag with the video of the person who you hear talking back there, up there.
I hadn't noticed that. So, and of course, now we stream live as well as recording, and people are watching live. Most of it's Flash. We use HLS as well. We use a variety of streaming technologies. But there's usually 10, 20 seconds latency. That's fairly common. So much so that we can't really, sometimes the chat room is watching something completely different and talking about it than what we're broadcasting.
Yeah, I feel proud of myself because what I'm doing now should be able to get it so if you have 1 million peers, you have like 5 seconds of latency.
That'd be fantastic.
Yeah. Well, the thing that's annoying is that the scaling properties of it are kind of the easiest to analyze. When things are going bad, it can add latency in ways because there's hiccups and things. But these like incidental hiccups and stuff don't change that much as you add more peers. I did this thing where it speaks a screamer protocol to get the data out to like most of the peers, and then something much more controlled for the last hop. So it turns out like the first and the last hops are where like basically most of your latency comes from. And in that intervening thing, there's kind of this rule of thumb that every time you add a factor of 1,000 to the number of peers, it adds about a second to the latency in the intervening thing. So the funny thing is that the actual like scaling blasted out there part isn't the big issue.
Interesting.
Because I kind of cheated by using a screamer protocol.
Well, we're getting ahead of ourselves because one of the things we're going to announce today is that we are going to start using BitTorrent Live and be a part of that. We're very excited about that. But before we talk about that, I also want to talk about how you thought of BitTorrent, how you came up with the idea, and what problems you solved and so forth, but not yet.
Okay.
In a moment. We're going to take a little break. We're talking with Bram Cohen, who invented BitTorrent and is inventing something new, which we will be using, and I'm very excited about that. Before we do that, I want to talk a little bit about Ford Motor Company and the Ford EcoBoost engine. Are you into cars at all, Bram?
Yes, I am.
Are you?
Yeah,
That's cool.
I drive a minivan.
They're very nice, fancy. Well, you got how many kids? 3?
3.
Yeah, you have to drive a minivan.
Yeah.
See, when you get to be my age and the kids start getting older, then you can drive a nice car again.
Yeah, I think I'd like to get a nice convertible at this point.
Yeah, there you go. You see what I'm saying? How old are the kids?
13, 7, and 5.
You need this. You need the 2012 Explorer, or perhaps an Edge, because here's the deal. Or maybe the 2013 Escape when it comes out. Here's the deal. These EcoBoost engines give you great fuel efficiency, but they pack a little wallop, which I like. This is one of the things, you know, we talk a lot about Ford's technology innovations in the cabin and the consumer electronics inside. But of course, they're a car company, and the engine is perhaps the most important technology of all. Most of us, because of where we live, still need gas engines, and Ford is making advances there as well as in hybrid and electric. But the EcoBoost is pretty amazing. I drove it when I first looked at my Mustang. I drove the SHO with the EcoBoost, and it's kind of shocking. You tap the accelerator, and you've got some power there, and yet you're getting great fuel economy. And they're doing it with a couple of technologies. Essentially, the EcoBoost reduces the number of cylinders, of course, to improve efficiency. But then you've got to compensate somehow for that loss of power and loss of torque. And they use 2 technologies to do that. One is direct injection, which by doing direct injection, you get a cooler, denser charge in those pistons that inside there that generates more power per drop of fuel. And then they have turbocharging, but not instead of one big turbocharger, which if you've experienced a turbocharged engine, sometimes gives you a little lag. They are reducing lag. They have 2 smaller engine-cooled turbochargers. They spool up faster. You get quicker response. And so the idea of a turbocharger, if you're not familiar, is energy from the engine's exhaust rotates the turbine wheels, which then compress the incoming air, so it's pressurized, which increases, again, the output for each drop of gas in there. So instantaneous low-end torque responsiveness, no turbo lag, great fuel efficiency, and in a nutshell, I've just described the EcoBoost engine.
And BitTorrent.
And BitTorrent. It's the same. It works exactly the same. The 2.0-liter EcoBoost is available now in the 2012 Explorer and Edge, and there's a 1.6 coming as well as a 2.0 for the 2013 Escape. You can find out more. You know, they got a great website, Ford.com/technology, where they talk about how this stuff works and all the other great technologies going into Ford vehicles. But the best way to really see it is to drive one at a Ford dealer near you. I did when I drove that SHO. It was so cool. It was so much fun. But then I drove the Mustang. And I said, oh, fuel economy be damned. I want a V8. But I didn't get a convertible, and I do regret that, Bram. You're absolutely right. So, so BitTorrent, well, first of all, why did you even, what were you trying to solve by creating BitTorrent?
The basic problem is a pretty straightforward one. You want to transfer really big files over the internet. And I wasn't thinking about any particular files or anything, or even file types. I made it just completely agnostic. There's a big file, download it.
Right. And normally it would be point-to-point, a server delivering it to you.
Yeah.
And the bandwidth constraints of the server and your connection was limited.
Was there a particular file that kind of pushed you over the edge to fix this?
Yeah, was this scratching your own itch? Or?
No, I worked at a startup.
Mojo Nation.
Mojo Nation, yeah. You heard of that?
Oh, yeah.
Mojo Nation kind of collapsed under its own weight, trying to do too many things at once and having all kinds of problems. But in terms of all the stuff I'd done on it, I thought my swarming distribution code was the really interesting stuff, where I'd done some interesting things on it. I thought it all had to be completely rewritten. From
Usually
scratch.
That's the case, though, isn't it? That the first one, you work on it, and then you go back and say, let's rethink this, and the second one's always better.
But that was the thing where progress had been made.
Right.
And so I wanted to do a product that was very, very strictly geared just towards that and nothing else. And the basic laws of physics calculation was very straightforward. There's plenty of upload capacity out there. Let's use it. The problem is this is bad upload capacity. We don't know what the rates are. We don't know what latencies are. And although I kind of cheated and I used TCP's congestion control for the whole thing. It's this funny thing. My latest project, I've actually learned about congestion control for BitTorrent. I'm like, I'm just going to transfer over a couple TCP connections at once and assume that black box works properly.
Interesting.
Which it basically does.
Interesting. But originally in BitTorrent, you didn't trust it.
Well, I did.
Use UDP or
no, I did. I just didn't know how it worked.
I get it.
Okay, I'll use it.
You had to
trust it. Yeah.
Yeah, so the problem is that the peers, you don't know what their throughput is, and they can just kind of die.
They
and
get
never,
some
and
guy
never
can
come
shut
back
down his
again.
machine,
yeah,
right?
And never come back again.
Right.
So there was a question of, is it possible to use these very poor resources of peers and do it in a way that's secure, for some definition of secure, and reliable, and does an effective job of utilizing all the available upload capacity.
Had there been any work done along these lines that you could refer to? Peer-to-peer was around already, or no?
It was. The approach I took was, people start looking at these problems. There were a number. At one point, I could have rattled off a list of like 8 others. At one point, I counted, and I knew of 8 others. And I can remember like 1 or 2 of them now.
Was Kazaa around by then, or?
Yeah, but Kazaa didn't really do the same thing, because you want this feature of uploading while you're still downloading. It's relatively easy to make it so that when you're finished downloading an entire file, then you start uploading and you can download from multiple peers at once.
Right.
But the more difficult problem is uploading bits of the file while you're still downloading.
So when you go to a BitTorrent site and you start downloading a file, you're downloading from a bunch. So we should maybe define some terms. You've got seeds, which have the full file, is that right?
Yeah.
And you have peers, which have parts of the file.
Yeah, well, a peer is any machine that's participating.
Because it could be a seeding.
Or a downloader. Frequently, people call peers that are downloading leechers, which I hate that word.
Yeah, because it's pejorative.
Because it's pejorative, and not only is it pejorative, it's wrong. They're downloading and uploading.
They're not leeching.
Yeah, a leech is one who downloads and doesn't upload.
Right. So that's one of the unique things about BitTorrent. You're immediately part of providing as well as at the minute you start downloading.
Right, yeah, that's the whole idea. Is a peer who's downloading has this upload capacity that's probably basically unutilized, and you want to utilize it. So you start uploading as quickly as you possibly can.
Right.
And the other huge thing was that in that system, the more people trying to download a file, the better, versus the old way, which is the more people trying to download a file, the worse.
Right,
because there was too much demand.
Right.
Yeah, and definitely less glitchy once you get more peers in there. Although there's some really basic kind of like laws of physics aspects of it that people really don't understand. Like sometimes people have these websites that people download stuff from, and they look at and they set up these rules because, I don't know, they feel this childish need to have rules and ban people if they don't follow the rules. But they'll like look at people's ratios of how much they're downloading to uploading, and so they typically decide, well, if you haven't uploaded all that much, you're bad. So we're going to punish you for being bad by only letting you download old stuff and not letting you download any new stuff. And then there's these pissing matches of like, look, I have no trouble getting a good ratio. How come all these other people have terrible ratios? It's like, well, it's very, very simple. If you join a swarm early on, there's the ratio of demand to upload capacity is much, much higher. If you join later, then there's all this demand, but there's way, way more upload capacity because there are all these peers there who have long since finished. So if someone has a bad ratio, the way you should punish them is in a way that makes it easy for them to improve their ratio, not in a way that makes it darn near impossible. Because if all you're doing is letting them download old stuff, you're letting them download things that
nobody else wants anymore.
Yeah, right. And there's lots of other people happy to upload to them really, really quickly. So that's good and all, but it's not what you want. And they're just kind of doing the exact opposite thing of what actually makes sense just from a laws of physics standpoint, where what you should do is if someone doesn't have a good ratio, you only let them download new stuff, and you don't let them download old stuff.
Well, I've been watching the stream here.
The latency is very good.
And it's been going down. Now, is that because we've been getting more viewers? Because it's gone from 3.3 second delay down to 2.3 second delay. Just while I've been sitting here.
Yeah, that's...
Or is that...
that's...
over-interpreting a number.
2.3 is really low. And actually, your real latency there is probably 0.3 seconds, and 2 of that is buffer. So typically what happens is there will be like just glitches that happen sometimes when there's stuff going on in the swarm, and what constitutes stuff is kind of involved. The different things that can happen to make it glitchy. But it doesn't have like a really set notion of what its delay should be. It kind of has this notion that it guesses what the best delay it could give you is based on how long, like what's the greatest delay of data that it's actually received is, and it keeps some amount of buffer beyond that. And if it finds that it's gone it's gone quite a while without getting anything of a high delay, it'll be like, okay, well, I'm now playing at a longer delay than is necessary, so I'm going to play back at like 90% speed until I get up to the amount of buffer that I think is appropriate. So if you're seeing 2.3 seconds, that probably means that, and you said it was over 3 before. So what happened was, it got some delays that were actually like 3 point whatever seconds, and then it waited like a minute, I think it is now, to start timing those out and go, okay, I can play back faster. Yeah. And then it played back at 90% speed, so it caught up at a rate of 0.1 second per second until it got down to 2.3 seconds. So 2.3 is like really, really like blue skies, nothing interesting going on at all. The data just kind of blasting out with no glitches. Now, that's good. We've had some that have had lots of glitches lately.
It looks good. I'm watching it. And if you're in our chat room, then you'll see that you can go there. I guess you just go to live.bittorrent.com/twitlive.
Yeah.
And okay, good. So everybody who wants to, if you're watching, in fact, do you want to do a torture test? You feel good?
I've seen thumbs up in the background there. So.
Everybody who's watching on Twit Live or twit.tv, why don't you try that right now? Go to. Do they need any special software? Can they just do it in their browser?
It'll prompt them to install. Okay. Our install path is going to be optimized a lot more than it is right now.
Just go to the downloads area, download and install. It's BitLive, is that the name of it? The client?
BitTorrent Live.
BitTorrent Live.
We maybe should come up with
And we're playing black and Flash. We're not, it's still using Flash.
Yeah, it's using Flash. We'd like to be using HTML5. Unfortunately, there are all these pissing matches about video formats and patent issues around that and stuff. So as an actual practical matter in terms of what's supported, by far the most pragmatic option is to use H.264.
But that doesn't matter from your point of view. It's just, it's just how it's
It's a container.
Yeah, yeah.
So how many people in the chat room, just out of curiosity, are watching on the BitTorrent live right now?
I've seen it spike by about 40 people since we just told everyone.
That's good. That's good.
Playback still going good?
Yeah, 3-second delay.
Shouldn't it get better the more people watch?
Well, if a whole bunch of people join at once, you kind of expect a little bit of fumbling to happen then. Hopefully no one really notices it because it should have enough of a buffer that the glitches that happen then don't put it over the buffer. General rule of thumb is, if you're talking about latencies added by scale, is every time you multiply the number of people in a swarm by 1,000, that should add about a second to the latency.
Got it. So is this the same? Is there a relationship between BitTorrent Live and BitTorrent?
No, people like assume that.
Just the name.
Yeah, well, and I created both of them. But
and you.
Yeah.
But other than that.
Yeah. Other than that, no, it's like when I did BitTorrent in the first place, like I was saying, I didn't know how congestion control worked. I just used TCP. And for live, I had to come up with my own very original concepts of congestion control and figure out how to make them work and stuff. And it's this very, very ground-up thing on top of UDP and is based on entirely different principles and is doing entirely different things from BitTorrent. And it's kind of funny because it's not like there's no obvious tangible way in which creating BitTorrent actually qualified me to work on this live protocol.
It's not related, really.
Yeah.
Interesting.
It's just a different problem that you wanted to solve?
Yeah, yeah. And I guess there's some amount of crossover in like layer 5 networking stuff. So,
now, there was some concern when we told people we were going to do this that their ISP was, for instance, blocking BitTorrent. You know, Sandvine. Remember, very famously, Comcast was using Sandvine to break BitTorrent connection.
Yeah, well, so...
First of all, how do you feel about that?
Well, the interesting thing about that is that the reasons they were doing it were largely technical ones.
Yeah.
Well, not exactly spurious, but they'd have this problem that there's like peak hours, right? And they don't care how much transfers people do during off-peak hours. You can do all you want because it's like if transfer capacity isn't used, it's gone forever. It's not like it costs anyone. The
There's not a big vat of transfer capacity that they're running out of slowly.
There's just no such concept as that. And so we decided to view this as a largely technical issue. So we rolled out this this protocol that we call UTP, which is a swap-in replacement for TCP. I hired some super experts in this thing. And it's based on doing congestion control based on one-way delays instead of packet loss. TCP is kind of playing bumper cars with how it decides when to back off, which causes really high latency and is just kind of bad. Where UTP is much more just kind of like, okay, it looks like the cars are getting a little too close together here. I got to back off a bit. As a result of which, and we've switched over most BitTorrent traffic to using UTP instead of TCP, and we actually went and paid competing clients to integrate it because it's good for everybody to have that in. So we went and gave them the engineering costs to do the integration themselves, and gave them the code. And so that's most BitTorrent transfers now are over UTP. As a result of which, ISPs just don't have this problem anymore. During peak hours, all the BitTorrent traffic just it gets out of the way it's supposed to. And that's just us being polite, doing good engineering. It's this thing that there was no need to have some big, political battle over.
Right.
It's just be polite, do good engineering.
Did you call Comcast and tell them that?
No. Well, I mean, they know that it's happened. They should have known.
Oh, yeah.
Oh, they know, all right. It just dramatically, massively reduced their costs and everything. And it's sort of like we're talking about it.
They should be patting you on the back.
Yeah, at least thanking us or something. We're talking about, gee, we seem to have created just a tremendous amount of value by pushing out this protocol that we did out of the goodness of our heart. So it got the ISPs off our backs. But it's this, bizarre irony where if we had made it so that things merely cost half as much, we could have, very easily charged for it and made a fortune. But instead, we just made this thing that solved the problem. And so we solved the problem. And it's like, wait, shouldn't we get paid for that? Can't we, offer the service that we won't turn this feature back off?
There you go. Yeah, all right. There you go. Now, that might not be legal. That sounds like blackmail to me. But
I don't know. It's just,
we
your
made
company.
a change.
You can do whatever you want with the protocol.
We made a change in the protocol. It was in your benefit. We'd hate to have to turn that off. It was really helped you, didn't it?
Well, and so just while we're on this topic, what do you think the solution is for congestion problems? Because there are real congestion problems at ISPs. But the side they're proposing is we're going to throttle you, and if you use too many bits in a month, we're gonna cut you off. And as you mentioned, transfer capacity doesn't work that way.
Yeah.
How should they solve it? This seems like a really good example of an intelligent way to solve it.
Well, first thing you do is you just do what the internet was designed for in the first place, which is end machines just decide whether they're sending something important and they back off if there's something more important that
doesn't work with Netflix, unfortunately, because everybody wants to watch their movie at 7 p.m.
Well, yeah, except it was in the person's instant queue already anyway. So with Netflix, there's this really unfortunate thing that their content contracts require that they stream everything instead of downloading it and caching it. If they were allowed to pre-download and cache everything, we would very happily help them do this.
That's a very good idea.
Yeah. And there still could be digital rights management to make MPAA happy. It would just be sitting there on your machine.
Yeah. Well, I tend to think of DRM as very misguided because usually your big problem is that the pirate experience is better than the for-pay experience.
That's exactly right.
And that's just backwards and wrong.
That's just exactly
the for-pay experience should be better.
Right. You want people to pay for it. Make it better.
Yeah.
Than the stuff they're not paying for.
Well,
it seems obvious.
You've got direct experience at this with BitTorrent.com, where you're selling legitimate content.
Yeah, we tried doing content deals, and our delivery on it wasn't good either, but a whole bunch of other people did pretty much the same content deals as we did, and it really just wasn't possible to make it work. Just the terms of the terms of the deals just weren't good. They just didn't offer the kind of flexibility you need to be able to make something work. Like Netflix, their original pricing would have been I believe, not allowed by the contracts that we had. Like Netflix was using this really illegal loophole because it was just sending you DVDs in the mail. And there's this doctrine of first sale that they can't put requirements on what you can do with the DVD after you buy it. So it was this kind of loophole in copyright licensing, which of course is now making the content industry tons of money because they're not willing to
It's a lesson that keeps getting repeated, but they don't seem to learn it.
Yeah.
With VHS and DVD rentals, etc.
Yeah.
Is BitTorrent Live going to be available for like a Ustream for anybody to broadcast eventually? Is that the aim, or is this more of a commercial level delivery system?
Well, I think everyone who has anything live they want to send out should be using this technology.
I'm all for that.
Yeah,
I think it's great.
And we have this very expensive infrastructure that's used to this day. Like most video content that people consume isn't going over the internet. It's going over the cable system and the broadcast airwaves and satellite and things like that. And it's using this system which is all about like send a whole bunch of data to everybody. And that does a good job of keeping latency low. And way back in the day was good because routing for it is totally trivial. And back when TV wasn't even really digital, the simplicity of the routing was very important. But there's fundamental problems with this. It's very costly and just wasteful to be blasting out all this data. And then it only reaches the people within that grouping that you're sending to, not like everybody on the internet. So it really makes sense to just take that whole infrastructure and replace it with a little bit of software.
Oh, sorry, I was watching the show on the show.
Yeah. That was good latency there.
Yeah, it's really good. It's almost an echo.
Yeah.
Yeah.
So it really, just from a technological standpoint, really should be that all this live stuff that people are consuming goes out over the internet, and I'd like to make that happen.
I think that's fantastic.
So from small to large, anybody should be able to use it. How do you approach the problem of people misusing it? Because sadly, that was the first thing when I said, BitTorrent's going to have BitTorrent Live with streaming video. They're like, oh, how are they going to stop the pirates?
I don't think you have to worry.
It seems so strange to me that that's the first thing people worry about. And it's like, oh, there's this great new technology, but like, oh my God, people are going to, like, I don't know, take these cars and use them to, like, stick up banks or something.
How are you going to stop some bank robbers?
Yeah, right. Yeah.
Cars are nice, but you know.
And I've always been very clear, like, guys, anyone who wants to make a good service, I'm trying to help you.
Right.
Like, make a good service. Like, work with me here. So piracy versus anti-piracy isn't really a battle I want to fight. I want everyone to be taking their stuff and moving it online, and I want to help them do that. And the fact is, for a whole lot of stuff that people watch on television, like all the first-run programs, which you want people to only see as they're going out for the first few, and like all the sports events and things like that kind of have to be over TV because you just can't really do it online without paying a ludicrous amount of money for it.
Well, and that's what's interesting about the online model versus the broadcasting model. In broadcasting, you build a transmitter, you've got upfront costs, but then if 1 million people or 1 billion people watch, it doesn't really cost you anything more.
Right.
This is the opposite. You know, there's bandwidth needs every single person's consuming bandwidth.
Right, but peer-to-peer fixes that.
Peer-to-peer solves it. And it really changes the economics of streaming so dramatically. And it's one of the reasons I really think that this is so important, you know. What are the challenges you see going forward to making this work?
Oh, well, we're still doing the finishing polishes on it, and boy, man, it's just more issues keep turning up. It's a really hard problem, and with BitTorrent, it's really nice not caring what the data is. It's just this giant black box. It's a string of bits. And
you now suddenly have to make deals.
Well, it's not. No. I'm not thinking about that. I just mean when you play back the data, it's like video data, so you have to play it back in something like the timing of when you got it. And if you don't have the data at the time you were supposed to play it, you have to either skip it or wait and decide which one of those you want to do. And if you get too far ahead, you have to start playing back faster. And then you can have CPU delays, and you have to make the CPU delays not cascade into actual latency going up on the stream. And of course, you have to worry about time. I never had to worry about time working on BitTorrent. It wasn't my issue.
Your only concern is fast. It doesn't really matter when. Fast.
And I've learned so much about time. There's all these deep philosophical issues about what time means. And I would find these really interesting and not horribly annoying if they weren't part of my day-to-day engineering work. There was a fix in a recent thing where we needed, so my entire thing, the whole thing, with one tiny exception, I only use monotonic time anywhere. I've written it specifically, so I do not care what the skew is between the clocks, between any two machines, ever. And one person on my team was like, hey, well, why don't you just make sure that there's an NTP server running on the machine? Like, okay, you are not allowed to ask that question ever again. And it sounds like an obvious approach, but really not a good idea. So I wrote everything so that it only needs monotonic time. And of course, there's like no monotonic time call built in from Python because few people understand how important that is. So we have like this itty-bitty little C library now that we wrote that's small, but it's, you know, it's a simple.
It's not intended for real time, really, right? I mean, is that the issue?
Yeah, people assume that the time call works, and the fact that there's like leap seconds and like a network time protocol server running, fixing the time and stuff isn't viewed as a big deal.
Right.
But for my stuff...
So you had to write your own code.
Yeah, for my stuff, it's
what
a huge
happens
deal.
Euronerd in our chat room asks an interesting question. You said each 1,000 people adds maybe a second. What happens if you get 18 million people watching? What if suddenly it's the Olympics?
It's exponential. So if you have 18 people, you'll have some amount of latency of actually going between peers, hardly any at that point. And so you go up to 18 million, so that's a factor of 1 million, so that's 1,000 twice. So that's 2 more seconds of latency added to the whole thing. Yeah.
Not bad. So it's exponential, not multiplied.
Well, it's logarithmic.
It's logarithmic. I got it. So it will scale very well then to very large numbers.
Yeah, yeah. And actually most of the problems we're running into are these small scale things. And the latencies are generally coming from like the first and last hop.
Right.
And running into issues with swarms as a whole having health issues, which aren't really related to the overall size of the swarm. It's due to like real world conditions that aren't the same as I run in my tests. I have very, very extensive tests. I have this whole tricked out system where I have an emulator and I can run as many peers as I want running my actual code, and they think they're talking to the internet and they think they're talking to a real scheduler, but actually it's just this scaffolding that looks like that. But they actually are communicating with each other through this thing that sure acts a lot like the real internet, and I can and I've written all my code so that it's completely deterministic. So at no point does it iterate over things in a way that's implementation dependent. So I can set up a schedule of what I want to have happen and run it, and then if anything goes wrong, I can run the exact same thing again and add in diagnostic statements to really track stuff down. And I find the thought of trying to develop a system like this without that just horrifying. I would just never get it to work. And there's like these subtle bugs that I got tracked down. They're like,
Would tell me if I'm off base. Would it be possible to one of the things our audience likes is the ability to scrub back. Would it be possible to cache some of this data as you've stored it? And
yeah, it's totally possible to do that. The thing that's fairly straightforward, not high on our priority list right now, but the thing that's fairly straightforward is, you know, what a DVR does, which is scanning back to something that you were tuned in for, and it's just remembering it. Trying to make it so that you can scan back even farther than that and download from peers is kind of
No, we don't need to do that. But do a DVR style.
Yeah.
Pause, resume, go back in time to the point where I started watching, that kind of thing.
Yeah.
People use that all the time. One of our providers, BitGravity, in their Flash player gives us that capability. I think VLC might
do.
Yeah,
it's the going to the bathroom feature.
Exactly.
Yeah, right.
Can you do that? Put that on your list. It's not a high priority. Just put it on. I think our audience likes to go to the bathroom. That's all I'm saying.
Every once in a while. Sometimes while getting up and going to the bathroom.
So we have a chat room, as you probably noticed, Brandon. They're very interested. We would, if anybody in the chat room has a question.
There was one question earlier that I meant to ask. It doesn't involve BitTorrent Live, but somebody wanted to know if you remember or know the first file shared over BitTorrent.
Well, it depends.
Didn't you put some stuff up yourself?
It depends how real of a file you're talking. Like, there's just like, here I grabbed some random file and put it down. And at one point, a friend of mine just put up a porn file for people to download, which didn't work very well because at the time there were all these like scammer porn sites that were trying to get you to install executables.
So people didn't trust it anymore.
Yeah. But the first real file was actually a friend of mine's a taper who tapes like hippie bands, and I think it was a Grateful Dead concert. But unfortunately, no one seems to remember which concert it was that he made available.
I like
and
that.
Got a whole bunch of people to download.
And I'm sure many of our audience has used BitTorrent to download Linux distros. It's a great way to get ISOs and all sorts of things. Somebody asked me to ask you about Yellow Pig Day. Yellow
Pig Day. Oh yeah. Because I was on math team stuff. So there's the Hampshire College Summer Studies in Mathematics, this math camp, which I went to. And the person who runs it is really obsessed with yellow pigs and the number 17. And so it's a sort of in-joke that there's yellow pigs. And you're
supposed to math nerd joke.
And you're supposed to wear your yellow pig shirt on Yellow Pig Day to notice other people who have done this. And I think if you're in Boston, you actually will see people wearing it, but not so many in California.
How about legal issues? Kay Jopi wants to know, have you run into any legal issues yourself over misuse of BitTorrent?
No, we haven't. No. We have, a very clear strategy of what it is that we're doing. My thought on these things is there's trying to stay out of legal problems by getting really deep into the technical details of the law and following the letter of the law and having a strategy. And then there's just not being skeevy.
Common sense.
Yeah, I'm a big fan of just kind of not being skeevy.
That's what Google should have used instead of that do no evil.
Yeah, do no skeevy.
Don't be skeevy. Yeah, don't be skeevy. Linux versions, there is a Linux version, isn't there, already, of this?
Of Live? Yeah.
Yeah, I saw OS 10, Windows, and Linux. Yeah.
Yeah.
And how about mobile? Would this be practical in a mobile environment?
Yeah, there are issues with just installation and the development and the environment it runs in, but we do in fact have an application that works from mobile.
Don't tell AT&T; they'll not be happy.
Yeah, sometimes people have said things like, "Yeah, this thing kind of got my my machine's firewall to freak out." It's like, yeah, it'll likely do that.
Do you have to do any port forwarding, or is it? I know with BitTorrent, you might want to have some dedicated ports. Is it similar to that, or?
It's helpful to do that if you're UDP will do gossip-based port opening much better than TCP will.
Right.
And I implemented it so that if your router will automatically open the same port to other peers, it will allow simultaneous open and not increment the port number when it does it, then gossip will work. And so that was sort of my threshold of how complex I was going to make trickery around helping peers talk to each other.
Somebody in the chat room says Khan Academy is using this. Is that right? Yes. They say yes.
Yes.
That's awesome. That's very exciting. It's working. It's working great for me right now. I mean, this is really fantastic. It looks good.
Yeah, around the middle of December, I just kind of got like a manic episode or something and just didn't sleep for a while and kind of went through and revisited everything in the entire protocol and really got the latencies way down.
It's pretty amazing, yeah. Anything else? Chat room, your chance to ask questions of Bram Cohen. Oh boy, now it's going really fast and I can't keep up. I'm going to have to open the browser directly.
Could it be, somebody asked if it could be adapted to make a new kind of web browser to help with bandwidth use. In other words, could you use this to, I guess, stream web pages?
No. The most interesting thing people are doing with web page downloads is the Speedy initiative out of Google, SPDY. Web page downloads are a really hard problem because you want to minimize the latency where you hit the server and just bam, get the data back. And you're doing it over TCP, and that's kind of the worst case scenario because you don't know what the rate is, and the person's download capacity could be anything across like a couple orders of magnitude of speed. So and your round trip time can be fairly significant. So if you have even an exponential ramp up, it can wind up being like a couple of round trips before it gets up to as fast as it should go. And typically web pages are pretty small, so kind of what you really want to do is have a not even TCP protocol where you initiate your request and it just blasts all the data to you with no regard to congestion control whatsoever. And there will be massive quantities of packet loss, but you just go back up and say, here's everything I lost, and it resends everything that it lost right there. And it'll make everything else on your net connection be utterly broken for like, the fraction of a second that it's downloading that. But presumably you just clicked on a link in a web page. You don't care about anything else on your net connection. You want that thing to load up
I guess unless you're watching
really
a video in the background or, people are multitasking, it might affect that, but it would be so fast, it probably wouldn't affect that.
Yeah, well, part of the problem is there's not a smooth transition between how big does a web page have to be before it's not the most important thing anymore. And to do that really properly, it's not my forte. And my intuitions around TCP-style congestion control aren't all that good. But it seems to me like there's some things that are kind of verboten to talk about would be a really good idea. Like if you have a high-performance web server, it would be, I suspect, a good idea to do a layer violation where the web server can actually remember what throughput it got to a particular IP address in the past. and tell the actual TCP connection underlying what it was, so it can start transferring at a significant fraction of that rate when it first starts sending data instead of having to ramp up to it.
Yeah. It does require right now 2 megabits upstream to use BT Live. Is that right?
It depends what the bit rate of the stream is.
So it has to do with what we're sending out. It's some fraction or multiple of that?
There are a few different numbers. There's how much, what the bit rate is necessary on the source of data. And for a lot of the plays that we're doing them in like a remote location or something.
Right.
And so we don't really want to send the original source out of there because we don't trust the net connection. So we have an RTMP connection to the real source of data. So that first hop requires the bit rate of the stream. The thing that's serving as the source of data needs, I like saying, 5 times the bit rate of the stream to be able to send it reasonably.
But that's our issue.
Yeah.
Mm-hmm. So at home they don't require.
At home it's a more complicated thing. Each individual peer should probably have at least 1/3 the bit rate of the stream and upload capacity themselves. You can get away with less, but it's a good idea.
So what are we sending? Does John, do you know, or Colin, do you know what we're sending right now? What is this? It's a 1 megabit stream. So you would have to have free 300 kilobit upload, let's say 368 upload capacity?
It's probably a good idea. You could probably watch it with much less upload capacity than that. But it might cause issues for the swarm as a whole.
A number of people are saying they're getting stuttering. What would that be?
That would be Bram needs to rewrite the smoother because it's buggy.
You got to so chat room. He's just got a little work to do.
Yeah.
You just filed a bug report, chat room.
Yeah. There's unfortunately. There's like
good answer, says I5.
Yeah, there were a number of places in the code which were just like rocket science where I had trouble reading my own code, and there's like one last place which is still like that, and I just added some stuff to it, and just by accretion it's gotten completely out of hand, incomprehensible, and I figured out how to consolidate it down now.
Start over.
I need to rewrite. The thing that like reassembles the data and sends it back, that's the thing that like is sending at 10% fast when it thinks it can and things like that. That just has bugs, and I can't even understand the code anymore, and I figured out how it should work, and I need to just completely rewrite it from scratch.
It's interesting because I'm not using a huge amount. I'm using, somewhere between 50 and 200 kilobytes a second down, and it's, most like 350 kilobytes up. So it's not using a huge amount of bandwidth. It's fairly sipping at this.
Well, if it's a megabit stream, that's
about right.
It's capable. So any one individual peer can have not very much upload capacity, although it's necessary for the swarm as a whole to have good upload capacity.
Sure.
And the thing I like to say is the aggregate upload capacity of the swarm should probably be like, if it's double the bit rate of the stream, you're in the clear. It'll be able to handle everything just fine. If it's only like 50% more, then
so that's where the 2 megabit number comes from. It's a megabit stream. You want to have roughly 2 megabit.
2 megabit
as aggregate.
Yes.
But for every 10 megabit connection out there, that subsidizes a few small ones. So,
yes.
Yeah.
Right.
Yeah, and it can use those 10 megabit connections real well.
Yeah.
Colin, is there a switch you can flip to go to 2 megabits? Just out of curiosity, I want to know what will happen. No? Is he asleep over there? Colin, hey, Colin. We're going to run anyway because it's time for, he might have gone home. It's time for, can you turn up the stream? Is that easy to do?
The volume?
No,
the
bit rate. Can you go to 2 megabits just to see what would happen?
He looked like,
just want to
I
watch
don't know why you do that, but all right.
Well, because we want to break it.
You want to watch it all fall over?
We're gonna wrap up because we want to see what happens. I want to see if it just gets like super cool, crisp. Is it an HD signal we're sending out to them?
No, it's 720 by
720p.
No.
720 by 405.
Oh, 405. Okay.
Yeah, the bit rate's much more important than the nominal.
Is it?
Yeah.
Than the lines. So, Bram, really a pleasure to meet you. Thanks so much.
Likewise.
Thanks for BitTorrent, which has just been amazing. How long has it been? 15 years?
Not 15 years. I started working on it in 2001.
Okay, not that long. 11 years. 10 years. Thank you for a great 10 years. BitTorrent is a miracle.
I couldn't upgrade my Warcraft without it.
That's right. That's right. And I'm very excited by what BitTorrent Live is already doing and what it will be doing in the future. And we're really thrilled that you're letting us be a part of this. That's very exciting. Thank you, Bram Cohen. BitTorrent.com if you want to know more. And our feed right now is at, what is it, BitTorrent? Live.bittorrent.com/twit.
Twit
Live. Okay. Got it. So thank you. Really a great guest. I hope you understood at least more than I did, because I don't. It all went over like that over my head. We thank you for joining us on Triangulation. We do this show every Wednesday at 4 p.m. Pacific, 7 p.m. Eastern at twit.tv live, but you can always watch after the fact. We make audio and video downloads available, of course, at our website and everywhere podcasts are. And you know what? This is a show you should subscribe to, because there's always somebody interesting and great on the show, and it's always a lot of fun. And if not, at least Tom Merritt will always be on it, and that's a hell of a start. Thank you, Tom.
Thanks, Leo.
Join Tom tomorrow for TNT Tech News Today, 2:30 Pacific, 5:30 Eastern, if Leo gets out of the way, at live.twit.tv or twit.tv. And are we just going to keep doing this? Are we going to, can you always go see us on BitTorrent Live too, Colin? Are we going to turn it off at some point, or we're just going to keep going?
Yeah.
So, if you had trouble watching us now, maybe try it another time later in the day or whatever. It's frozen now on a really ugly face of mine, but that's okay. That's probably him turning up the bandwidth is what that is. Thanks, Colin. That was my idea. This Week in Radio Tech is coming up next. Thanks for joining us. We'll see you next time on Triangulation. Thank you, Bram. Really, really neat stuff.